All right, 18. dy dx for this kind of gross little thing has 4 terms. Um, First and foremost, we did this one in class, and the first thing I did was rewrite this as 3x to the negative 1, so I didn't have to use the quotient rule. And then the rest of this is pretty straightforward. It's just making us use some of those more awkward derivative rules that we don't use as often. So when we go to find our dy dx, first term, straightforward. Unless you use the quotient rule, in which case it was a little less straightforward, but you just did some suffering on your own. So bring that negative 1 down, subtract 1, we get negative 3x to the negative 2. The second is an exponential. Derivative of an exponential is going to stay an exponential, just like our e to the x, but it's always going to have that tail of that ln of 5, or whatever the heck our base was. Pi over 4. I know it scared us, made us think we were going to have to do some trig, but pi over 4 is just a fancy constant, so derivative of that is 0. And then we have our derivative of arctan. And the derivative of arctan is 1 over 1 plus stuff squared. So in this case, we have to recognize that our arctan does indeed have something more than just an x as its argument, which also means that I need to have the derivative of that stuff as my tail. So if we clean all of this up, we ended up with negative 3 over x squared plus, there's really no better way to write this one. Then we could put the 6 in the numerator of this thing. Up to you if you left that as 36x squared or 6x quantity squared. Those are the same thing. So there is your final answer to number 18.